Good morning, everybody. Welcome to another edition of Power Hour. Today we're going to talk about the digital to virtual transition in the substations. Today, I am Jeremy Anderson. I'm Senior Vice President of Engineering with NovaTech. I have with me Garrett Schmidt, who is our Director of Product Management, and Mark Doss, the Energy Field Director with Dell. And we'll be going through a little bit. Little housekeeping rules again for those of you who have not been in a Power Hour. If you have questions along the way, in your GoToWebinar control panel, there is a question panel. You're welcome to type in your question there. We'll either answer it right there back in the panel, or we'll answer it live depending on what the question is and where we are in the presentation. With that, today we'll talk about the evolving power grid, that transition to the future that we're seeing, the changes that are taking place. We'll talk a little bit about virtualization and just a brief overview for anyone that isn't very familiar with virtualization, kind of explain what that is. And then we'll kind of go into the virtual substation, or what may be the substation of the future, some architecture, what some of the components will be, and that sort of thing. So the transmission distribution grid have been relatively the same for many, many years. 100 years. Generation has been large generation facilities, oil, gas plants, coal, nuclear, hydro, and they're usually where the source of power begins. It goes to the transmission grid, as you know, to the distribution grid, distribution substations, and on to the consumer, whether it's commercial or residential. The scale of the grid has grown drastically, but the general architecture for many years was relatively unchanged. But it's changing, as we all know, as we navigate towards new ways of generating and consuming power with renewables and electric vehicles. The electric utilities are going to have to change the way they operate the electric grid. One of those changes is going to be the distributed energy production and storage. Distributed forms of energy, wind, solar, geothermal, they're located in different locations than the traditional forms of generation, and their output is not consistent, right? Sun doesn't always shine, the wind doesn't always blow. Downtime is more evident from those. So forecasting and managing this and balancing this generation is much more of a complex task. So we need to change how we do things. As the global consumption rises, with using more electricity with electric vehicles and that sort of thing, the pattern of consumption is even changing. Power systems continue to have higher penetration of inverter-based resources, and so they have less synchronous inertia sources, right? So big coal plants, big gas plants. So if you think about what happened a few years ago in Texas, when we didn't have, when a lot of the generation is from wind, we have all of this new generation that can change the frequency, can cause a lot of issues in that. These interconnections, the frequency doesn't reach under frequency load shedding levels for large unplanned losses of generation, right? Utilities are required to respond really quickly to loss of generation. that can cause frequencies to dip below normal levels. So one of the things we have to start doing is have fast frequency response resources, right? These resources need to respond within, 15 to 20 cycles when frequency drops as little as, less than a quarter of a hertz. So like an example would be the ERCOT requirement is for fast frequency resources to be added within 15 cycles when frequency drops below 59.85 hertz. Because that time is so short, you need to be able to measure that accurately and quickly within a few cycles. So how do you do that? You do that with automation. And one of the ways you can do that is with a fast frequency meter. So we're kind of bringing this in the digital world. Fast frequency meters are going to be needed. We've developed some firmware for our meters that allow us to have front-end filtering to mitigate aliasing effects of battery storage systems. And we can actually reach 1 millihertz accuracy within 6 cycles. This fast measurement capability is a fraction of the response time of a traditional meter, and that allows fast frequency response of 15 to 20 cycles. As we go back and talk a little more about this, we need to leverage the more complex grid automation. They'll be key to controlling and balancing the increasing number of producers that are out there, right? The more solar, wind, distributed solar, rooftop solar, as that becomes more and more complex, automation will really take hold and be required. So how do we do this? One of the ways will be, what we're going to talk about shortly. But let's first step back and talk a little bit about the current, microprocessor-based substation. Everybody on here understands the current way we do everything. Typical example of a cabinet. Now, obviously, these the pictures aren't exactly what you would see, but there's several IEDs, right? Each performing a core function, whether it's an RTU, a detective relay, a meter. Each of those functions are pretty simple. They're computationally speaking, they're doing a specific job. They're usually on a microprocessor-based architecture, an embedded architecture, but they're connected, using copper wire to whatever asset they're monitoring and controlling. And that can be expensive. There can be miles of copper wire inside of a substation. And also, this design requires lots of maintenance, right? You don't just have one rack in a substation. Some larger substations have dozens and dozens of racks with hundreds of IEDs, all independently wired and cables pulled. It's inefficient use of space. O&M costs get driven up, and it's not really scalable. As the substation grows, you have to possibly build a new control house. It works. It's worked for many years, but it is not necessarily the way to continue doing things. So fundamentally, each of these devices, it just runs a software function. So the first step to achieving a virtual protection, automation, and control designed substation is to take each of these devices down to their core software function and remove the hardware. So one of the things that everybody is beginning to look at is, take partnerships with software vendors, taking that core functionality of those IEDs and deploy that as a virtual machine. You take each function out of each thing, deploy it as a virtual machine, and then run that on a hypervisor on a server in the substation. It leads to a reduction of overall complexity. It's space-saving design, and it also removes all that copper wire that we're pulling everywhere. But the same level of capabilities and very, very scalable. For a quick conceptual discussion, let's talk about what a virtual machine is for any of those that haven't really dealt with them. Traditionally, every substation function is handled by a dedicated device, right? We talked about, there's RTUs, protective relays, meters, fault recorders, whatever they may be. And virtualization just abstracts the software function of those devices and puts them onto a server. The server would have a bare metal hypervisor running. That's the, in lieu of an operating system, that is the operating system. On top of the hypervisor, you create virtual machines, and they're just digital representations of those physical devices. And the number of virtual machines you can run on a server depends on the hardware specs of that server. How many CPU cores, how much storage, how much memory. So let's talk a little bit about some deployment architecture. Multiple ways to deploy virtual machines. Single server deployment would just have the hypervisor running some number of virtual machines. A more complex system would have a management system for multiple servers running in a cluster. The advantage of that, of having more servers, would be a higher level of redundancy and failover, high availability. Think of a primary system and a disaster recovery system as an example, or you take a server down for maintenance. You don't need to take down your protection schemes or your RTU or your HMI. All of this is much more likely scenario to run a multi-server deployment in a substation. So as we standardize on a common hardware platform and introduce virtualization, there's a real potential to save, to save not only operational costs, but physical costs. We could reduce the number of IEDs by 50%, sorry. Reducing overall sprawl, we could really, reduce the size of the control room, while also reducing operating costs. Maintenance costs go down by 70% or more. It also allows you to increase reliability, safety, security, manageability. You can run more analytics this way. There's a lot of benefit to moving to a more virtualized, substation design. And this doesn't have to be all done at once, right? You can run some applications in the virtual environment while still continuing to use many of your physical IEDs at the same time. I'm going to turn it over to Garrett so he can continue on with a little more detail on some of our VPAC and some of our product innovations.
Thanks, Jeremy. So in the introduction here, Jeremy kind of showed you the overview and the introduction to virtualization. And what I want to highlight with virtualization is it's not really a new technology. It's not something that's just been created in the last few months as this idea for how the power grid of the future is going to be built. Virtualization is a mature technology. It's been used in other industries, especially in the IT side, for years. I think what we're seeing now is this shift in this new concept of adopting mature technologies into a new space and finding a new way to use them to achieve the needs of the energy market. So to that end, we've seen now on this slide an overview of the VPAC Alliance. So VPAC stands for Virtual Protection and Control. And the VPAC Alliance is really sort of a consortium of member companies that have joined together to build this mission and to fulfill this mission, which is to develop a standards-based, flexible, manageable, and interoperable platform for the smart grid of the future. You're going to see on this slide of members a big mix of vendors. NovaTech is one of them, of course, and a number of utilities. What I wanted to point out is the VPAC Alliance is actually accepting new members right now, and they are especially interested in having additional utilities join. So if you're out there and you're interested in having your voice heard for the future of the power grid, I would encourage you to go check out the VPAC Alliance and see if joining is something for your utility. So enough of that little commercial there. What we're going to show now is really starting to get into how virtualization and the VPAC Alliance envisions what a substation looks like in the future. So what we're looking at here is a demonstrator rack. It's got sort of the major components of a virtual substation inside. Starting at the top, you see time synchronization, so a highly precise PTP satellite clock. Underneath it, you're going to see some Ethernet switches, which are there for the purposes of networking. You're going to notice that they're also redundant. So using HSR or PRP, we're building out redundant networks for high reliability. Moving on down the chain, you'll see a slide out KVM and thin client for HMI capabilities. So we still anticipate that the virtual substation in the future requires an HMI. Therefore, we have an HMI in this demonstration rack. Next, we have merging units. So merging units are the measurement devices of the future. So that's used to connect to your transformers and lines and do all the monitoring and measuring capabilities and feeding that back into the protection, automation, and control servers you see down below. So once again, everything in redundancy. We've called out a couple of specific models of some items and some products we're going to highlight in the next few slides, just to give you a sense of what's out there today and to kind of help with that transition and thought process of how we might move to a virtual substation in the future. So on the next slide, just a commercial on Kronos Series 3R PTP satellite clock. This is NovaTech's top of the line model. It's an NTP server and a PTP Grandmaster. We have a variety of power supply options for that, so you can power it what you like. And what we really focused a lot of effort on for this particular product is flexibility in the different outputs. Recognizing that not everyone is going to go PTP overnight, so this is a very future-proof model. Supports a lot of different high-rig outputs as well as NTP and PTP all simultaneously. For very high reliability applications, we have an oven-controlled oscillator option for when you have very long holdover requirements in case your satellite link were to somehow go away. And then finally, as I mentioned already, with redundancy, we have support for HSR PRP. So that takes care of our timing requirements. Now, in terms of the server requirements, I'm going to give Mark an opportunity to speak to some of the offerings from Dell in terms of substation hardened servers. Mark?
Yeah, thanks, Garrett. So Dell Technologies, I think everybody knows, has been in the data center server and end user compute business for a long time. We recently, within the last few years, entered what we refer to as the edge area, which is essentially creating an industrialized, ruggedized servers to be able to operate in harsh environments. And this is for various different industries. But we've also made a significant investment in the electric utility industry, getting our first ruggedized version of the PowerEdge XR12 IEC 61850-3 compliant. So we had a third party company be able to validate it against what the IEC 61850 standards were to operate in a substation. So this opened up the digital substation market for us and really helped us create this idea of a standardized substation platform. Think of it as a server being able to run workloads in a distribution substation. We showed earlier the virtualized protection and control functions. You're going to hear about an RTU function. We've been able to validate various cybersecurity workloads. So what we're seeing is creating more of a digitized or software-defined substation. So that's what these servers are able to provide, running a virtualization hypervisor, multiple workloads on 2 or 3 servers for redundancy to be able to help enable this digitization or modernization of the substation. The PowerEdge XR12 was the first server of a portfolio. We have a next version available today that's finalizing its 61850 compliant testing. That would be the XR4000. We have 2 or 3 others in the pipeline to be able to go through the certification as well, to be able to provide more CPU, more storage as required as we get more and more application heavy workloads to be to run in the substations. And this is a standard Dell server, so you get all of the enhanced services, from a secure supply chain features. You have built-in cybersecurity capabilities, a rich set of management tools to be able to monitor and manage the hardware and the server and report it back, and ultimately help drive that reduced CT or total cost of ownership or total cost of management operations that we mentioned earlier. Garrett?
Thanks, Mark.
Yep.
So Mark kind of gave an overview of a server that is truly hardened for installation in a substation environment. And of course, the next question naturally is, well, specifically, what kind of software would run on it? And Mark mentioned a few examples of security and protection. So Orion VX is the newest product from NovaTech. It's actually officially launching and entering the market this week. And Orion VX is a virtual controller to you. So it will run on the server as a virtual machine. And if you're familiar with any of the Orion products, it follows very closely along with the rest of that product family in terms of functionality. So Orion VX is an ideal solution for the VPAC substations. Fits very well into that architecture that we showed a few slides ago. What's exciting, I think, about virtualization is it starts to open up new possibilities, things that we haven't even necessarily thought about as a use case, an application, or even a product. One of those benefits of virtualization with our Orion VX is the ability for it to act as a front-end processor. Because we now are really limited in hardware resources on the server only by the actual server selection, as opposed to a dedicated hardware appliance, like, for example, an Orion LX Plus, which has a fixed hardware footprint. We can now assign a lot more resources to a particular software application or virtual machine on a server. And so that allows us to scale things up. orders of magnitude. So with something like Orion VX, because we can scale that up, we're able to support massive amounts of points, DMP points, and also higher device count. So we can connect to actually more devices in the field, which make it an ideal solution for a front-end processor, putting this in between all of the grid devices and the SCADA system to aggregate that data and kind of bring it all in as a, harmonize it to a single protocol, for example. So Orion VX is really part of the answer to the question I think Jeremy posed before, is how do we make this transition to virtualization and the grid of the future without completely throwing out everything we know and starting over. So this helps us to maintain some semblance, I think, of what people are used to from the user experience and everything. So next slide, Jeremy. I think this slide illustrates that. So if you've ever used one of our Orion products before, all of that same functionality that's in an Orion LX Plus or Orion SX is available in Orion VX. It is the same field-proven software, firmware, extensive protocol library, all of the tools, and even the NCD configuration tool is the same. So once that Orion VX virtual machine is installed and deployed on the server, the user experience is identical. The capabilities are identical and even expanded, like I mentioned, with the front-end processor application. Going even further, going virtual offers more redundancy options. So I think, earlier in the slide deck, Jeremy mentioned it about live migration and the possibility for high availability and things like that. So it becomes even more reliable than what was previously available. It's key. So just to demonstrate or illustrate Orion VX as a front-end processor, here you can see a very simple diagram where Orion VX is running as a virtual machine, maybe on 2 servers for redundancy purposes, and connecting to what could be thousands of substations, pole-top devices, or even edge devices, could be IoT sensors or fault line indicators or very simple things like that. Orion VX is now residing in the data center at the enterprise and connecting into all of the enterprise applications. So just a new possibility, and one we've seen a lot of interest in so far. Next slide, Jeremy. Orion VX also allows you to do some new things in terms of SCADA. So for smaller utilities, especially, Orion VX brings forward all of the same SCADA features that are in the Orion HMI tile annunciator, email alerts, and things like that. And can become a very capable total SCADA solution. It's an all-in-one option. So once again, I think this is just highlighting some of the benefits of virtualization. So kind of wrapping this all up and putting a bow on it. I think we've demonstrated today, or just tried to give you a very high level introduction to what's going on in the grid, and introducing some of these new technologies, or new to us technologies. Grid transformation is going to require additional things. Even beyond virtualization, we can anticipate much higher need for other technologies that have been either never utilized or only lightly utilized till now. So we anticipate we're going to see more and more of that in the next few years. What we should take away from this primarily is that virtualization is a foundational technology to the future of substation operation, and that the result is faster, more flexible, and easier to maintain. Jeremy, did you want to make any final comments here before we transition to the poll?
One thing I wanted to make sure everybody understands from, and I'm sure most do, is the number of VMs you can run on a server can vary, but in most cases it can be multiple, many VMs on one server. depending on the workload and depending again on the core count and what that workload requires. But you can potentially run, many Orion VXs or Orion VX with a number of protection functions or other analytic, software. It really can, you can really do a lot. And the hypervisors now are so good at sharing the resources effectively that, they've proven out so well that you don't even notice that you're running not on embedded hardware. In fact, you probably know, the way you probably might notice is stuff can even run faster. So, this is, like Garrett mentioned, this is a mature technology outside of the utility space. Everything you do in your normal life runs on a VM, probably out in a data center somewhere. So this is, we're finally starting to, explore this in the utility space, and I think it's definitely has some legs, and it's worth looking at. So one of the things we wanted to do really quick too is show a few polls, just some questions, try to get some feedback from everybody on their thoughts on virtualization in the substation and that sort of thing. So I'll be sharing, I believe it's 5 different questions here. If you don't mind answering them along the way, it'll kind of get us to understand more of what everybody's thinking about when it comes to virtualization. And I'll leave these up for about, 30 seconds or so, and then we'll move to the next one. So this one's pretty evenly split. I wanted to give a little feedback on this one because we're curious on the way this is going to go. This seems to be very evenly split between 1 to 3 years, 3+ years, and not sure. So that's kind of what we're expecting from the industry right now.
We did get a question about sharing the general poll results. Hit that one in the last question, Jeremy. This one about merging units, it's dancing around a little bit. It looks like it's about a 60-40, 40% yes.
Yeah, and we will share in the follow-up after there'll be an email follow-up with any questions and answers that came in, as well as we can share these results of the polls with everybody so that everybody else can kind of see what other utilities and users are thinking.
It's like we've got fair distribution on this one too. It's like about 1/3 is IT, a little more than 1/3 is SCADA, small percentage, 10-15% for communications and 40% for other.
All right, well, thank you guys for answering that. As this is a new idea in many utilities, it's interesting to see where people are at in their thinking of this. So thank you for taking that time. Want to thank Mark and Dell for joining us today. If you have questions on servers, because that is obviously something that's quite new to put in a substation, please reach out. We'll provide Mark's contact information in the follow-up email as well. That way, any questions pertaining to that sort of technology or sizing of servers, all those sort of things, we can follow up on. Mark, do you have any final comments or anything you want to add?
No, I appreciate the opportunity to participate in the webinar, Jeremy. I enjoyed it. And again, if anybody has any follow-up questions or interests, please feel free to reach out to me. We're happy to get back to you and answer any questions that they might have with this. So thanks a lot.
Yeah, thank you, Mark. And then from our standpoint, if you have any questions on virtualization from NovaTech side, please reach out. We're happy to talk with you, show you examples of some deployments that are already out there. We'd like, happy to provide you with a demo version of the Orion VX should you want to test it out in your lab, anything like that. So, please reach out. Even if you just have questions on what we're seeing in the industry. We're actively participating in the VPAC Alliance, so we get a lot of feedback from utilities and other vendors out there of what this is looking like as we go forward. So definitely reach out if you have any questions at all. With that, we know this is a fairly quick one today, so we'll give you back a little portion of your day. Thank you guys so much again. If you have any questions, please feel free to reach out, and I hope you have the great rest of your day.